What I'm gonna talk about today is the XAI software, which is about counterfactual explanation via prototype learning. To begin, what is counterfactual explanation? For example, consider a person whose loan application has been rejected by a classifier. In picture, the financial advisor is the classifier. For this person, counterfactual explanation provides what-if scenarios wherein they would have their loan approved. Since the goal is to generate perturbations of an input that leads to a different outcome from the classifier, counterfactual explanation has parallels with adversarial examples. Let's see why we need to utilize the prototype learning. Look at the table below. For the input instance, there are 4 counterfactuals, and the first has a problem. First one has a problem. If you see the education column, the education value has changed as doctorate. However, there's no change for an age value. In common sense, this is unrealistic because if you want to raise the education level, we have to spend at least several years. To consider this common sense, we have to utilize prototype learning, which is the method to set the prototype instance from the real and feasible data set, and then make the counterfactual to be generated similar to the prototype instance. Method. This is the architecture of our method. The input goes into the model. Then the input instance is perturbed until the classifier's prediction changed as the target label. Also, in this perturbing or training, input instance changed to be similar to the prototype instance. These are the notations, and F is the machine learning classifier pre-trained on the training data set, and V is the dimension of the feature space, which includes continuous features and categorical features. And YCF is the counterfactual output, and XCF is the counterfactual example. So the objective function is composed of these 4 functions. First, classifier prediction loss, and second one is proximity function, which is to make the counterfactual instance close to input. And third is the DPP function, which is determinant point process function. For more details about this function, please refer to paper below. And for the last, this is the prototype function, which I will explain from now on the next slide. We can denote the training data set as D. Then we can define D prime as the subset of D containing all elements such that their output label is the counterfactual label. From the subset D prime, we can select P instances close to the input data, and then by averaging them we can get prototype instance. And the L2 distance between these and counterfactual instance becomes the prototype function. Experiments. This slide is about the experiments, and we use adult income data sets, which is one of the most popular financial domain data sets. And setting and metrics were set by referring to the paper below. As as you can see, there are difference between two experiments. Both are experiments without and with prototype learning, respectively. Compared to the above experiment, the following experiments show that the counterfactual is more similar with the prototype instance, especially in terms of age. And there's a website address where you can find the code of this model. So thank you for your attention, and this is the end of my presentation. Thank you.